everybody, this is Larry. This is me going with Q3 of the weekly contest 252. Minimum garden perimeter to collect enough apples. Hit the like button, hit the subscribe button. Join me on Discord, especially if you like these contests. People go over the contest right after the contest. So if you are looking for somebody to kind of do the contest with, come on in. Come hang out. I'll probably be doing that more as well. But yeah. So this one I struggled a lot with during the virtual contest. As you can see, it took me 32 minutes though. I would also say that this is a product of my virtual contest because I definitely might have cheated if I did this in an actual contest. And the reason is because, and you can actually watch me solve this live during the during my virtual stream, and I solved in 32 minutes, maybe watching in 2x or something like that. But I go for my really full process. So let's go over the long way that I did it and got a seed on, and then we'll go over the cleaner ways of doing it. So the way that I did it, to be honest, is that I brute force. I have this code here. I brute force per pattern. I for each length, I kind of looked at the total, and from that, to be honest, I looked at the pattern, and when I saw the pattern here for just some small ends, I thought, okay, what about the derivative of that, right? And I just took the delta and I print that out, and then I noticed that the delta of the deltas, the second derivative, had a pattern. So that's basically what I have here. When I printed out, I saw a pattern. I don't know if this is advisable, to be honest, but I guess I had some intuition about it. But sometimes I would also say that one, this is probably not going to be an interview question, though, knock on wood, maybe I'm wrong on this one, and if so, then good luck. Two is knowing myself. I know that I'm really bad at math, though maybe I could have gotten this one if I did it more smallly, but I was just stuck for a little bit. And when you're stuck, sometimes just do the best you can, grind it out, and that's basically what I did. I did the brute force. I just looked at this pattern for a long time. I know that I said everything about like, oh, this derivative, the second derivative, the second delta, all this stuff in like 1 minute, but actually it took me like half an hour to kind of look at that pattern one at a time. And once I did that, once I saw the pattern, I actually implemented the pattern. And this is my solution one. And this is very funky, but basically I matched, I try to match row from row for row, this output to what I have here. And if you watch the video, I actually do this literally to kind of generate this ridiculous looking formula. So yeah, I don't know how to explain it. So, I mean, I will explain it, but I don't know how to explain it in the context of what I did, because what I did was, that's what I did. I basically did a while loop here. The one thing I would say is that I ran this for 10 through 15 to make sure that it's a small enough number so that this for loop worked in a linear way. Because my intuition when I first saw this problem was that there's going to be a formula and I'm going to binary search on it, and that's how you would get the answer, right? And that is a solution. I'm going to, don't look ahead just yet. That is the solution, but I didn't know how to do it that way. I have to do this linear way, and with this linear way, I had to get it to be fast enough. And fortunately, the inputs are small enough that this works for this one. But I don't. It is what it is. I get, in that sense, I'm a little bit lucky, but I also tried really hard for it. So but maybe I should have thought about it another way. Sometimes you're stuck. Sometimes you have bad days, but if you grind hard enough, hopefully you just get it good enough. Yeah. And then, but I would say, if this was an actual contest, I would have cheated. And how would I cheat? Well, as I said earlier, I did brute force for pattern, and if you watch my actual video, I actually talk about this thing OEIS a bit, and at a certain point, about maybe 5 minutes in, something like that, I actually don't remember the timing, I basically said, okay, if this was a real contest, I would have cheated. And how do you cheat? Well, it turns out that because this is a sequence, you can use this thing called the Online Encyclopedia of Integer Sequences, which is way often abbreviated as OEIS. People talk about this all the time, but basically, literally, if you ran the brute force for the first 5 numbers, you would get something like this, and then you could literally search this sequence, and then you would have seen the sequence. And then this sequence, you have this formula, right? And if you have a formula, then it becomes trivial. Well, or at least a lot easier. And it becomes a lot easier because this formula, as you can see, it's going to be monotonically increasing. This is just an intuitive thing. I mean, you also know because you could take the derivative and then you see that the derivative is always positive, etc., etc. We will skip the calculus for now, but just know that for this formula, it's binary searchable. So yeah, so given that, I actually copy and pasted here. I actually implement this after the contest. This is correct. Yeah, so yeah. So basically I have this formula, I binary search on it, and this is straightforward binary search stuff. Basically for, oh yeah, I think one thing that you have to return is the parameter. So this is basically what I did to kind of convert it from the number of boxes or whatever, the number of offset times 2 to get, on both sides, and then times 4 to get the parameter, right? So this is basic parameter stuff. I also have it here. Hopefully that's understandable. But yeah, and apparently people also say that if you have the pattern, you can also use Wolfram to calculate this. But yeah, also the other thing is that, well, let me finish this binary search thing first. So the binary search it's binary search on the answer. It's something that comes up a lot on Leetcode and Code Force and competitive, and maybe a little bit less on interviews, but it's still a good technique. It's basically the answer of, hey, if there's if we have, as you can see, this formula will always be increasing, and then therefore you go, okay, let's say you have needed apples, right? You could change this to a binary function of Boolean function of true or false by, okay, let's say we have f of 10. Does f of 10 have enough apples? And so forth, right? So that's basically how you do binary search, and you kind of work it out. Because this is always increasing, you would answer the question, for some x, you would have false. Well, no, 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 and then at a certain point, you do have enough apples, and it becomes, false, 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 true, right? And then the way that I always said it is that your bounds. I'm going to choose my bounds to be inclusive. I need to just record a binary search video because I think this comes up a lot and I keep on doing it. But yeah, so this is inclusive. What I mean by inclusive is that this is left and right, and that means that both left and right could be a possible answer. So actually, I guess 0 is not a possible answer, but that's okay because that's always false anyway. And then here, that means that because it's inclusive, when left is equal to right, that means that your inclusive bound has one number, and that is your answer. So if you get off by 1, that's basically something I would do. Middle, it doesn't matter. And then here, basically what I do is I actually visualize this, right? Let's say mid, let's have a pointer. If this, let's say, let's just point it at a true thing, right? So this is true. Let's say f of x have enough apples. Then what does that mean? That means that our answer, where is our answer, right? Our answer is going to be it's going to be mid, where the pointer is at, and to the left, because we know that this will never be the answer because this is the answer, right? So this is never the answer, and everything bigger than this will never be the answer, so that you can remove it. And by removing it, you set the right to mid because now you want to set the right bound to this one, including this one. Similarly, let's say you have your arrow here. Let's say you have a false. What does that mean? Well, we know that this is no longer a possible answer. This is no longer a possible answer. And everything to the left of that is no longer a possible answer, right? So I'm just going to write x, x, x. So this is x'd out. These are no longer possible. So that means that the possible answer is going to be everything to the right, which means mid plus 1, which is here. Even though I know this is false, but it's a possible answer because we don't know this yet. And everything to the right. So then that means that left is equal to mid plus 1 for that reason, because this is, again, inclusive bound, meaning that left and the right are both inside the answer. And that's pretty much the idea here. That's how much, and once you kind of ask yourself the same questions, this should be clear as binary search. So, another way to do it, apparently, is by Wolfram. I actually did not do it this way, but you can actually do an inverse function because you have this formula that's, let me type this in. I don't know how to use Wolfram that well, but okay, well, yeah, but the idea is that this is a function where you can find the zeros, right? This is literal. You want to set, this formula is equal to needed apples. So you can actually do this, not in all one per se, but there are ways to do it. This is literal, what's it called, numerical analysis. There are a lot of ways to kind of come up with this answer, right? So that's basically what I would say. And you can do this in much faster time. It'll converge better than this bisection thing. But yeah, so that's basically the answer. There is a more intuitive answer, but I was able to get it because I'm really bad at these visualization stuff, to be honest. So yeah, so basically, I'm going to give some credit to Lonely Dreamer on the forum. I think this is probably my favorite thing that I kind of scanned through for visualization. But the idea is that, okay, for each ring, you have this thing, right? For example, for 5, you have 5 plus 6 plus 7 plus 8 plus 9 plus 10. So then now you kind of just, you can make the observation and you could do the math with respect to, the sum of numbers, which is, in this case, is just 5 plus 6 plus 7 plus 8 plus 9 plus 10. And then you times that by, you times it by 4. And then you also plus the one that is 5 plus 6 plus 7 plus 8 plus 9. And then you times that by 4. I think they actually go over here. Yeah. And then you have these answers, and then you could do it that way to kind of either binary search or just get the binary search or just get, yeah. And then you do it that way. Hope that makes sense. I could draw it out a little bit, but basically the idea here is that, okay, yeah, let's just say, for example, in this case, you have 5, right? So 5 is going to be 5 plus 6 plus 7 plus 8 plus 9, or another way is that x plus 1 plus x plus 2 plus, x plus x minus 1, right? Oh, well, so you have this thing times 4, and also you have this thing times 4. I'm a little bit fast here probably, but I think once you have this visualization, you can kind of figure out why this is. And here, of course, this is just 4 times the summation, which is x, maybe I may be off by 1 here actually, x times x plus 1 over 2 minus, oh, the other way around. Okay, so yeah, you could expand this to, okay, fine. Let me just, instead of writing the formula, this is equal to 4 times sum of the first x plus x minus 1 numbers minus sum of the first x minus 1 numbers, right? And of course, this is a formula that you can derive. I'm going to leave it as a homework at home because I'm going to get an off by 1 somewhere, but given enough time, I trust you can do it. This is equal to the sum of the first x plus x, or x times 2 numbers, minus sum of the first x minus 1 numbers. So now that you have these two, you can again either do the linear thing, or if you kind of just do the math and then sum of this to get a formula, which is probably just this formula, and then you can now binary search on it. So that's basically the way that probably is the proper way to solve it. Yeah, so here, and yeah, that's all I have for this one. Hope I gave you a lot of possibilities, an explanation for how to solve this one. Let me know what you think. And yeah, you could watch me attempt this problem. It took me half an hour or more than half an hour on this problem. You could kind of see how I grind through it, watching 2x, maybe even 3x, just to kind of, sometimes you don't know the answer, there are other ways to do it as long as you keep trying and keep grinding and keep going at it. Cool. Yeah, and you can watch me solve this problem during the contest live next. What a weird problem. Okay, let's go. Q3. Minimum collect enough apples. Apple in every. Okay. Minimum perimeter of a plot. Such. What a weird problem today. Weird set of problems. Need inside or outside parameter. Okay. So this is 1. We need 1 apple. The square part of side length 1 does not contain any apple. Why not? Side length of 1. Let me read this again. Oh, because, okay, I see. Because it has the thing. So this is just binary search with some kind of math, I think. I mean, it's definitely binary search if you're minimizing it, but try to figure out the name of the function or the function. So, okay, so there's 8 for 2. Or I mean, let's just call it 1. I think they do the side length to fool you. 1, 2. This is where I need pen and paper, and I wish I had pen and paper with me. Some napkins, but I don't have a pen. How do I want to visualize it? Okay, so instead of visualizing it, let's brute force this a little bit. Minimum parameter of a plot. Okay, so it's parameter. And parameter is just 4 times the length. This is so much math, so weird. Okay, fine. Let's play around with that. Let's actually code that out. Because I'm too lazy to figure out. Or maybe I have pen and paper. Okay, length is in range of 1 to say 10, just to print it out. Print go length. What is it? So, okay. For x in range of -1 or negative L to L plus 1. For y in range of negative L, L plus 1. Yeah, okay. I think my length is off by a power of 2, but that's okay. X. Oh, right. I guess I don't really need this, but it should return the same thing every time, and also just print out length, so I have something to print on. Okay, so am I right on this one? This is 12, which is, I don't think this is right, because this, oh wait, no, this is right. It tells you that this is 12. It's just that this is the parameter. Okay, so 12, 60, 168, 360. What is the pattern here? Do I know the pattern? Paladin, 1248, 108. Just the delta. What is that? 1248. And this is what I write on a paper, but I don't have paper right now. So does that make sense as a pattern? Maybe not. I think one thing that I could do to cheat is OEIS, but maybe I'll, just because I'm practicing, this isn't even a live contest, I would just hold up a little bit more. 198, 192 is a magic number. And then 300. Okay. Do I know anything about this delta progression as well? It feels familiar, but I don't. And also to double check and see I do math wrong, because that would be really sad. I've done that before. Well, of length 2, what does this mean? That means that it shows up 1, 2, 3, 4, 5, 6, 7, 8 times. And then for distant 2, it would be Yeah, this is the distance too. So actually, and this is distance 3, 4, 5. This is like the triangle numbers or something weird. Yeah, because once we figure this out, this pattern out, we can binary search on it is my answer. But how do you do it? This is where pen and paper would be very helpful. This is not just multiply because it has the same xy as well, but now it's 2, 1, and 1, 2, and so forth. So it's a little bit more awkward than just straight up. This is a little bit unexpected. Let me. 300, 438, no, 428. Is that right? This minus that. Yeah, I guess that's right. No, wait. 432. I can't do math right now. Okay, 432. That's not a number I'm familiar with. Unless I'm just wrong. This is so mathematical. Okay. Is there a way I can abuse symmetry? Okay. I keep on saying 8, but it's 12. So 12 is for 1. This is so mathy. Like the algorithm part isn't that interesting. The mathy part is interesting, but not in maybe not in a good way. I think the other thing I can do is actually do something like this just to see where it goes to. Maybe this is actually too slow. Sometimes, so what I'm doing here is just trying to see if it grows too fast. If it grows fast enough, and maybe this is something that I would have done on my computer instead of on Leetcode, but it's too lazy to set up. The thing is that if it grows fast enough, then I actually just can brute force for small numbers, and then But this one seems like 3 million. I think the answer is like less than 1,000 for, or maybe not, maybe more than 1,000. Maybe 10,000 is probably the answer for 10 to the 15, but we still need a slicker way to do the math because the way that I'm doing it is clearly not Gucci. 1260, 300. This pattern doesn't really make sense to me. Okay. Should I cheat? Okay. So yeah, if you see something like this on a contest, I would actually do OEIS. And honestly, to be honest, if I was doing this on a real contest, I would do OEIS. But now, because I am doing it as a practice virtual contest, I would have gotten it. Because in an OEIS, I probably would have solved this in like 5 minutes and then moved on to the next one. But that's okay. We're here to learn. It's a virtual contest, so I can take some luxury here. But I am reaching a point of confusion. Actually, no. So I said 10,000, but actually they tell you, oh wait, no, this isn't 10 to the 15. So I think my 10,000 is probably still right. That the max number is probably 10,000. If you can do this in one time, you don't even need to do binary search, possibly, depending on your function. Is this formula right? I guess so. And this is 598. Is that right? 588? Both of them are weird numbers. Yeah. Okay. Is there another way to think about this? 2 is this right? 48. Why is this only 108? This grows in a way that is weird to me. So it has, let me think about this for a second. So going to 2, I'm trying to figure out a recurrence that makes sense. So for each number, So we times 2. Okay, so we had at least times 2. And then for each number, we also, so times 2 just scaling it one way. But then we have basically 1, 2, 3, 4, well, 1, 2, 3, 4, 5, 6, 7, 8 things to consider. And that doesn't even make sense for greater than 2. Huh. Really don't know how to do this one in a way that isn't cheating. What? You're 432. Huh. Oh, and this is the parameter. So actually, this is even 1,000 for 10,000. So my 10,000 is probably very pessimistic. So we can definitely pre-calculate it if we. So one thing that you can do, if I really, if I'm feeling it, 1,000 cube is only 1,000,000,000, right? So I could do this in a server, and then I would actually print out 1,000 numbers as a pre-calculation, and then just do a binary search on that one or something like that. So that's never an answer. So I already know how to do it in 2 different answer way, but I'm trying to do it the clean way of just 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 try to find a pattern. Pattern. Can I do just something dumb? No. I mean, yes. No. I can probably just do something dumb with breadth-first search, maybe, but I'm not sure that that's any faster than this, to be honest. A weird cute way. Did I mess that up? No, 192 is right. This is so weird. I actually expect this to be at least times 2, but maybe I was wrong. No, that doesn't make sense, the times 2 part, because everything doesn't project. So then you have to get numbers that are GCD, and then it becomes like almost like a sieve, but I don't think that makes sense. Spent a lot of time on this problem. Let's look at where this grows. Okay, so this is what I thought it would be, but is there a pattern here in this? In every row, 60, 84, 108, 132, 156. Oh. Hmm. I mean, this is your pattern, but this is such a weird pattern, isn't it? There's a delta of 24 on each row. Thought I saw it. Okay. I mean, this is codable now, so I have the answer, but to be honest, I don't know. This is, learnable. Okay. So, what does this mean? That means that the second derivative is 24. And what does that mean, right? Or the third derivative? Yeah, because this is the second derivative, and the third derivative is 24. Yeah, you can do this in linear thing, so we should do it in linear then. Yeah. So, okay. So, x is equal to 1. Total is equal to 0. Row is equal to 0, say. Now let's just say 12. And this is 12. Let's say 24. Yeah, so then while true, total is added to the number in the row. Row adds. I think I'm missing one derivative. This is such a weird way of writing it too. Not gonna lie. But sometimes, yeah, you just have to do how you do. Do how you do. Okay, I think I'm off here, but okay, so because 1 is 24. Total is less than needed apples. Something like this. Maybe I'm off by 1 or 2 or maybe a lot. Let's print it out and see. Okay, that's all. Let's just comment this for a second. Yeah, whatever, let's do this. Okay, that was useless. Also, we want this times parameter is 4, and this is actually, this is times 2. Maybe? What? This shouldn't give me a 1 though, but. Oh no, 8 is right. Let's see. 5048. Okay, so I'm off by something. That's a little bit unfortunate actually, but that's okay. 2, 6. Is this the number that we had before? 24, 60, 144? I don't think so. Wait, am I printing the right thing? Yep. So 1 is 12, 2 is 48. So I'm actually off by a little bit in the starting thing. This is such a weird problem. Yikes. So 2 is 48. So the delta here is, maybe I need this delta first. Oh, wait, this is right, but I don't wanted to keep my paste in my paste bin. That's why. Okay. Oh, jeez. Okay, so this is right, even though I'm not gonna lie, I'm not proud of it. Is this right? I actually forget my sequence. I don't think this is right. This is off by a little bit still. So somehow it gets the right answer. I guess it's just close enough, but it's gonna get me wrong answer somewhere. Okay, so we have, what was the sequence that I get? So it's 12, 48, 108. So that's already wrong. So we want this to be 108. We want the delta of the delta to be plus 24. This is such a weird way of doing it. Larry, why are you weird? Weird. Yikes. Okay, let's step back a second and do it again. Now what am I doing here? So this is the, so I'm printing out, this is the total, this is the delta, and then the third delta is, the second derivative is the one that's this funky number, and it starts at, what's this, 36? Oh my, oh my, oh my. I mean, this is doable, it's just annoying at this point. So, okay, so 160, 160, so we have 48 as the derivative, and then you have second derivative, which starts at 36. So total we have 12. For the second row, we take the, this is such, like, I might as well have cheated on this one, to be honest, because this is such a mess. Also, did I mess that up? Nope, I'm okay. So this minus 24, so this is 36. And actually we want this. Something like this. Let's see. This is still wrong. Am I closer though? Tell me why. This is not going too fast. This is such a silly way of doing it. But this is what happens when you're not good at math. And I'll be the first to admit I'm not good at these kind of mathy, geometry-y things. So, but you know, sometimes you just have to do what you have to do, and this is what I have to do. Let's actually copy and paste this a little bit, so I can at least, I don't have to keep on rerunning this when I do it. This auto bracket thing is keep on messing me up. Okay, so we want 2 to be 48. Now this has to be plus. Yeah. 60, 156, is that right? No, 60, 168. And our first delta is 48. Right? Is that not right? Nope, this isn't right. The delta should be less. Now, this one is exhausting, especially the way that I'm doing it. Trying to build from this formula, which is terrible. There's probably an easier formula. I'm doing it a stupid way. All right, let's take a look. Instead of scrolling back and forth, I need more than one screen also, but that's besides the point. So here, the delta is, say, 48, but now this is 26, 36, sorry. 36, 48. Row is so it should go from here to so first row has 12. How am I doing this? I think I'm just doing this in a weird way. Spending so much time on this one. Okay. The second here. What is we want the row to have, what is this? This 96, what does that mean? That means that that's the next row, not the current row. So maybe, so this should be 108 actually, not 48. So we started at 48, and then we want to add 60, right? This is 60, but instead we added 48. Okay. Oops. Is this closer? Let's see. This would work better if Leetcode was not so slow. Can I get anything right? There's probably a better solution to this. That's okay. To refresh. Manual formula time. From 60 to 216. This is not right. Wah, this is such a sad one. Okay. Okay, let's say row is, let's just, come on, no, this started rough, right? Okay, let's say row is 60. We let, no, that's not right. Row is 48. So we add this, okay. And then now the next row is plus 60. Well, the 48, so delta is actually 60, say. I'm getting very confused, to be honest. Okay, maybe I just need to do this. What am I doing? What am I doing? Is this not right? Okay. I mean, this matches at least, I believe. Let's see. I just needed to step back and refresh my mind and everything, apparently. Let's see, 61, 68. Okay, so this is the formula, though I'm not proud of it, but hopefully, at least it shows you that grinding helps. And also 630 is, yeah, I get the right answer. Let's try the max case while we're here, since we already took a lot of time anyway. So what's it, 10 to 15? 6, 9, 12, 15. I had to, oh. Isn't it 10 to the 15? Maybe I have an extra 0. Oh, I forgot to remove the print statement. The price it went 60. Okay, wow. I actually was wrong on that one. I thought it'd be less than 10,000. So this may actually take too long. So we might need to do a binary. Well, I can't do binary search the way that I did it, unless you have a better formula. Okay, let's just give it a YOLO. Am I good enough to YOLO? Let's give it a YOLO. I always spend too much time on this problem. Okay, this is clearly not the way that I would recommend it, but you know, an AC as an AC. Okay, let's see. Yeah, thanks for watching. Hit the like button, hit the subscribe button. Join me on Discord. Let me know what you think about this problem, other problems, whatever you need to do. I'll see you later. To stay good, stay healthy, to good mental health. I'll see you later. Bye-bye.